Hello dear students, good evening to one another. Welcome back to the chemistry class. In the last class, just I have given the snapshots, objective points which we are going to study in the topic electrochemistry. Let's begin the topic part wise. As per our convenience, we have divided this electrochemistry in three parts. Part first, it deals with the conductivity, conductors, or conductivity concept. Whereas in part 2, we are going to deal with electrochemical changes, either electrochemical cell or electrolytic cell, right? So let us begin the topic with electrochemistry. Now, electrochemistry. Electrochemistry. The first point is regarding its definition. Yes, everyone will know about the definition. What is meant by electrochemistry? Electrochemistry is a branch of chemistry which deals with the study of production of electric current from the energy liberated during a spontaneous chemical reaction. Is it right? The production of electric current from the energy liberated during a spontaneous chemical reaction. Now, what is meant by spontaneous chemical reaction? What is meant by spontaneous chemical reaction? Non-spontaneous chemical reaction. The reaction which takes place on its own without requires any external energy are called as spontaneous chemical reaction. The reactions, if it requires some amount of external energy to take place in one direction, such reactions are called as non-spontaneous reaction. So in any spontaneous reaction, its energy of the reactants will be decreased. That means usually maximum reactions are exothermic in nature. Exothermic reaction. So now about the exothermic and endothermic, you know that. What is meant by exothermic reaction? Exothermic reaction. Exothermic means the amount of energy is liberated. Delta H is negative. Whereas the endothermic is nothing but delta H is positive. Delta H is positive. For spontaneous reaction is the reaction which proceeds in one direction without any external energy. Or we can say the reaction takes place on its own, are called as spontaneous chemical reactions. So during that reactions, whatever the energy liberated, that energy we are converting into electric energy. So conversion of chemical energy into electric energy and utilization of that energy, utilization of electrical energy to bring about a non-spontaneous chemical reaction. Non-spontaneous chemical reaction means which do not take place on its own, which requires some amount of external energy. So therefore, I can say whatever the production of electricity produced during the chemical reactions, what the electricity produced from the chemical reactions, that is used to bring about a non-spontaneous reaction. So a branch of chemistry which deals with the interconversion or conversion of chemical energy to electrical energy and vice versa is known as electrochemistry. This is the definition. Now, in this electrochemistry, the main basis of electrochemical reactions are redox reactions. Redox reactions are involved in the electrochemical phenomena. So here, some of the points we'll discuss about a few points regarding the redox reaction. The basics, introduction part. In the introduction part, what we are going to do is redox reaction. Redox reaction. In class 11, unit number 8, the topic redox reactions we have studied in detail. So from that topics, let us select a few points. What is meant by oxidation and reduction reaction? Oxidation and reduction reaction. So here, the first thing, oxidation reaction. Oxidation reaction. Oxidation reaction. Oxidation reaction and reduction reaction. Can you define oxidation reaction? Addition of oxygen is called as oxidation. Am I right? Addition of oxygen is called oxidation. Oxygen is electronegative element or electropositive element? Oxygen is an electronegative element. So I can say addition of oxygen or addition of any electronegative elements. The note, electronegative element. Addition of any electronegative element is also called as oxidation. So here two definitions. First one is addition of oxygen is called as oxidation. Addition of electronegative element is also called as oxidation. Removal of hydrogen is known as oxidation. Addition of oxygen, removal of hydrogen. Now, this hydrogen is electronegative or electropositive? Electropositive element. So, removal of electropositive element is also called as oxidation. Next, in terms of electrons, these are the basic definitions. Hydrogen, oxygen, and electron. Three definitions. Oxidation we are going to define in three terms. In terms of oxygen, in terms of hydrogen, in terms of electrons. So, in terms of electrons, oxidation is defined as loss of electrons, right? So, here, loss of electrons is also called as oxidation. So, five definitions are available. In terms of charge, if from an element, if one electron is lost, what will the charge carried by the ion? For example, if an element A, element A in its ground state, its charge is 0. From this, if one electron is lost, minus electrons, we are going to get A plus. So plus charge 0 to plus charge. If one more electron is lost from this, if one more electron is lost, the next charge will be A plus 2, and one more electrons A plus 3, and so on. Loss of electron is called as oxidation. During the loss of electron, what will be the positive charge? Positive charge bond increases. So, in simple way, I can say increase the positive charge. This is first definition. Second definition. Third, fourth. Increase the symbol. Increase in positive charge. Increase in positive charge. Rs decrease in negative charge. Decrease in negative charge. For example, if it is A3 minus, if one electron is lost, A2 minus. If one more electron is lost, A minus. One more electron is lost, A0. Look at the charge. -3 to -2, -1, 0. Negative charge decreases. Decrease in the negative charge or increase in the positive charge is called as oxidation. So totally I have given 7 definitions for oxidation. Similarly, opposite to this are the 7 definitions of reductions. So you can directly write the definitions of reductions. It is oxidation. Then what is the definition of reduction? Here is addition of oxygen is called oxidation. Removal of oxygen, addition of hydrogen, gain of electron, increase in negative charge, decrease in positive charge. Opposite to the oxidation are the definitions of reduction. So 7 definitions of oxidation, 7 definitions of reduction. We have defined. So the reactions in which both oxidation and reduction reactions takes place simultaneously, such reactions are called as redox reaction. The reactions which involves the simultaneous oxidation and reduction reactions are known as redox reactions. Is it clear? Okay. So now let us consider some simple examples and we will continue the topic. So first one simple example. Simple example. Cu copper plus Zn. So here charge is not mentioned. So zinc plus Cu plus Zn, copper 2 plus N plus zinc. This gives us to Zn2 plus copper. Next example, copper oxide plus lead, which gives us to lead oxide plus copper. Just I will do two example. In these two reactions, is a redox reaction. You can identify which substance which undergoing oxidation and which substance which undergoing reduction. Okay. So now consider this one. First reaction. What is the charge on copper? It is +2. In the product side, what is the charge? 0. Look at it. Positive charge decreases. Positive charge decreases means it is gain of electron. Gain of electrons is called as reduction. So this undergoing reduction. This is a reduction reaction. Reduction. Whereas copper, next is zinc, oxidation state is 0. 0 to +2. Positive charge increases. Positive charge increase means increase in the plus charge. Increase in positive charge is known as oxidation. So in the same reaction, oxidation as well as reduction is taking place. This reaction we can say it is a redox reaction. It's a redox reaction. Now, oxidizing agent and reducing agent. Two more definitions. Oxidizing agent and reducing agent. Oxidizing and reducing agent. How you are going to define these two terms? Oxidation, reduction. Oxidizing agent, reducing agent. So here, oxidizing agent and reducing agent. The substance which undergoing oxidation is called as a reducing agent. This is a bit confusion. The substance which itself undergoing oxidation is known as it is a reducing agent. So in this reaction, Cu2 plus undergoing reduction, copper 2 plus ion undergoing reduction. Since it undergoing reduction, it is an oxidizing agent. The substance which undergoing oxidation is called as a reducing agent. I think definitions are clear. Oxidizing agent is one which itself undergo reduction. Reducing agent is one which itself undergo oxidation. Okay. The substance which undergoing oxidation is known as a reducing agent, or the substance which undergoing reduction is called as oxidizing agent. Now can we identify which one is oxidizing and reducing agent in this reaction? Copper oxide is converted into copper. Initially oxygen is with copper, but in this case copper is alone. So from copper oxide to copper, one oxygen is lost. So it is loss of oxygen. Loss of oxygen, gain of oxygen is oxidation. So loss of oxygen is reduction. Can I say this is reduction? Reduction. Copper oxide undergoing reduction, so therefore it is an oxidizing agent. It is oxidizing agent. If one is oxidizing agent, 100% the next is reducing agent, and it must not undergo oxidation. Addition of oxygen minus oxygen. So one oxygen is added, so this process is oxidation and this is reducing agent. So in the reactions, we can identify oxidizing agent, reducing. The basic required for the electrochemistry is oxidation and reduction. Basic definitions: oxidizing agent and reducing agent. Usually in objectives, in many times what I observe, they have asked some of the questions like arrange the following in the increasing or decreasing order of their reducing power, oxidizing power. Arrange which of the order is correct for reducing power of the substances, oxidizing power. So here oxidizing power or reducing power that indicates oxidizing power is nothing but tendency to undergo reduction, because oxidizing agent means it's undergoing reduction. Oxidizing power means tendency to undergo reduction. If it have maximum tendency to undergo reduction, its oxidizing power is more. If it have minimum tendency to undergo oxidation, then its reducing power is less. Don't confuse. Tendency to undergo oxidation is called as reducing power. Look at this. Substance which undergoing reduction is called oxidizing agent. Oxidizing agent. Oxidizing power means tendency of this substance to undergo reduction is called as oxidizing power. If it having high tendency, then its oxidizing power will be more. And vice versa. So this is about oxidation and reduction. Oxidizing agent, reducing agent, oxidizing power and reducing power. In the introduction part, we can note these points. Only in the introduction part, definition of electrochemistry, definition of oxidation, reduction, oxidizing agent, reducing agent, and oxidizing power and reducing power. Is it clear? Now, let us discuss the first part of electrochemistry. That is about conductors. So here, as we are dealing with electricity, production of electricity, current, production of current from the energy liberated during a spontaneous chemical reactions, right? So as we know that all the substances which do not conduct current. So few of the substances, some of the substances which are good conductors, whereas few are bad conductors. So based upon its nature, substances are classified into two types: conductors, insulators, or conductors and non-conductors. And one more category, semiconductor, that is another part. So here we are talking about the conductors. Conduction is its tendency, conductor of the substance. So conductor and insulator, the substance which allows the passage of electric current to pass through it, are called as conductor. And you know some of the example. Usually metals are the good conductors. All strong acids, strong bases, salts, and impure substances are said to be good conductors. Whereas bad conductors are insulators. These are the substances which do not allow the passage of current to pass through it. Thus, such substances are called as bad conductors or insulators. Such as examples: rubber, wax, glass, etc. So those are bad conductors. Right? Conductors and non-conductors are simply insulators. So in this conductors, it is of two types: metallic conductor and electrolytic conductor. So we are discussing in part first about conductors. The substances which allows the passage of electric current to pass through it are called as conductor. It is of two types. One is electrolytic conductors and metallic conductors. Metallic conduction, metallic conduction, and electrolytic conduction or electrolytic conductors. Two types in conduction. One is metallic conductor, it is also known as electronic conduction, and this is we can call ionic conduction. Now, so what is the differences between these two, metallic conduction and electrolytic conduction? And what are the factors which affecting the conductivity of the substances? So here first, metallic conductions. So as we know that metals are the good conductors because which allows the passage of electric current to pass through it. So how the electric current is passed through a metal surface or through a metal, how the electric current is passed. So what are the carriers of electrons? Current is flow of electron. So in metal surface, as we know the structure of a substance, the metal surface consists of atoms which is surrounded by electrons, a close packing of atoms. So each atom containing number of electrons which revolving around the nucleus. So when one electron is passed from at one end, so number electron get repulsion. So electrons are the carriers of current. So in this case, conduction is due to, in case of metallic conduction, it is due to movement of electron. This is due to movement of electrons. Whereas this is due to movement of ions. Electrolytic conduction is due to the movement of ions. That means ions are the carriers of current, whereas in this case electrons are the carriers of current. And given this, there is no transfer of matter. It do not involve any transfer of matter. Or you can say, during the passage of current, the composition do not vary. The composition of a metallic substance, it remains fixed. So during the conduction, it do not involve the change in composition. So here, no change in its compositions, no change in its compositions, But through an electrolytic solutions, when current is passed through it, it undergoes decomposition. It is transfer of matter. It decomposes. It undergoes decomposition. Now, with increase in temperature, when temperature is increased, metallic conduction decreases. In this case, it decreases with increase in temperature. That is inversely proportional. So simply I can write conduction. Metallic conduction is inversely proportional to temperature. Whereas in this case, this ionic conduction is directly proportional to temperature. Some of the differences between metallic conduction and electrolytic conduction. Now let us discuss a few factors which affecting the conductivity of metal as well as electrolytic solution. So now simply we can assume that what are the factors. We'll discuss about the factors affecting on electronic conduction or metallic conduction. So this type of conduction, metallic conduction, it depends upon factors affecting on this. It depends upon nature of metal and its crystal structure. So it depends upon nature of metal and its structure. It depends upon number of valence electrons. If more number of valence electrons, conduction increases. Also, valence electrons. It depends upon density of crystals, density of metal. It depends upon density of metal. It depends upon temperature, nature, its structure, valence electron, density, and temperature. Whereas this electrolytic conduction, because we are going to discuss about electrolytic conduction. So electrolytic conduction means when electrolyte is added to the solution, electrolytic solution. Through this solution, when current is passed, ions are the carriers of current. So therefore, it allows the passage of electricity to pass through it. So when current is passed, it ions which carries the electron from one end to other. So this conduction depends upon the inter-ionic interactions, because in electrolytic solutions ions are there. If these ions are free, these ions which carries the electrons from one end to other. If between these two ions of inter-ionic interactions, if it is present, then these ions are busy with another ions in the solution. So therefore, these ions are not free to carry the current. So conduction is less. So it depends upon inter-ionic interaction. It depends upon inter-ionic interaction. It depends upon size of ion. Size of ions. Smaller the size of ions, more will be the ionic mobility, therefore conduction increases. So conduction directly or inversely proportional to size. Conduction is inversely proportional to size. As the size increases, conduction decreases. Conduction decreases. Size. Next, viscosity of the solution. Viscosity of the solution. Viscosity. If viscosity is more, then it retards the mobility of ions. In more viscous solutions, the ions which moves with less speed are viscosity which slow down the speed of ions, therefore conductivity decreases. So it depends upon viscosity of the solution. It depends upon nature of electrolyte as well as nature of solvent. Nature of substance, solute. That means whether the added salt is an electrolyte or non-electrolyte. If it is electrolyte, which is split up to give ions, therefore conduction is more. If it is a non-electrolyte, then conduction is less. Non-electrolyte, because ions are not there. So if it is an electrolyte, whether it is strong electrolyte or weak electrolyte, if it is strong electrolyte, it completely dissociates and readily forms the ions, conduction is more. If it is weak electrolyte, partially dissociated, so number of ions will be less, conductivity is less. So it depends upon nature of electrolyte as well as nature of solvent. Polar solvent and non-polar solvent. If polar solvent, it easily polarizes the ions, charge will be separated, ions are readily forms, so therefore conduction is more. So in polar solvent, when ions are entered, it is surrounded by number of solvent molecules. The process of surrounding the solvent molecule to an ion is known as solvation. So it depends upon the process of solvation also. The greater the solvation energy, in case of water it is called hydration enthalpy or hydration energy. Greater the solvation energy, that means more number of water molecules are surrounded. When it is surrounded by maximum or more number of water molecules, its speed will be decreases, because if it is free, it moves very fast. If it is surrounded by some number of ions, its speed decreases. So when its speed decreases, conductivity decreases. So it depends upon the nature of electrolyte and nature of solvent, viscosity, size of ion, inter-ionic interactions, as well as temperature, etc. Temperature, etc. So these are the factors which affect the conduction of metallic as well as electrolytic solutions. Metallic conduction and electrolytic solutions, which depends on these. The few points we can make. The next, we talk about the electrolytic conduction. Electrolytic conduction. Electrolytic conduction. Like metallic conduction, electrolytic conduction is also obeys Ohm's law. Some of the basic terms which is required, basic terms of this conduction concept. The basic terms. First one is now I'm talking about electrolytic conductors. Electrolytic conductors. The substance ions conduction is process. In electrolytic conductors. So now you know about the term electrolyte. What is meant by electrolyte? The substance which is split up to give ions when added in water or solvent. The substance which is split up to give ions are known as electrolyte. If it readily split up to give ions, it is called strong electrolyte. Readily or completely when it dissociates, that is called strong electrolyte. If the substance which partially dissociated, partially ionizes, such electrolytes are called as weak electrolyte. For example, strong acid and base are strong electrolytes. HCl, H2SO4, HNO3, NaCl, KCl. So these are the examples of strong electrolyte. Weak electrolyte, acetic acid is partially dissociated. Ammonium hydroxide, HCl, hydrocyanic acid. Next examples of weak electrolytes: ammonium hydroxide. Ammonium chloride is strong electrolyte because it is a salt. Carbonic acid is a weak acid which is partially dissociated. All the carbonate salts usually these are weak electrolytes. Bicarbonates. So examples of electrolytes, non-electrolytes, strong electrolyte, weak electrolyte. Now I am dealing with electrolytic conduction. The conducting power of the ions is known as conductivity. Am I right? The conducting power of ions present in an electrolytic solution is called as electrolytic conductivity. Conductivity is nothing but the conducting power of ions is known as its conductivity. Now, like metallic conduction, this electrolytic conduction also obeys Ohm's law. Now, these are some basic terms we are collecting from the physics. Ohm's law. So, Ohm's law, what is the statement of Ohm's law? Ohm's law. Ohm's law, it states that, it's the statement of Ohm's law. The current flowing through a conductor is directly proportional to the potential difference across the conductors. Potential difference. The current flowing through a conductor depends upon the potential difference across the conductors. If you use proportionality symbol, I is equals to 1 by R is its constant, so I can write V by R. The strength of current flowing through a conductor is directly proportional to potential difference across the conductor and is inversely proportional to resistance. Directly proportional to potential difference, inversely proportional to resistance. Whereas R is a resistance. R is a proportionality constant known as a resistance and it is expressed in terms of ohm. The resistance is expressed in terms of ohm. Its unit is ohm. It is expressed in terms of ohm. Now we are going to define some basic terms like resistance, resistivity, conductance, conductivity, molar conductance, and equivalent. This is the Ohm's law. Ohm's law statement is right. Or by way of we can write V is equals to IR. V is equals to IR. V is equals to IR. So where R is resistance, it is expressed in terms of ohm. Now, this first term, resistance is represented by R. So this resistance. So what is the definition of resistance? Resistance definition: obstruction to the flow of current is called as resistance, or opposition to the flow of current is known as resistance. Simple definition of resistance: the opposition to the flow of current or obstruction to the flow of current is called as a resistance, right? And this resistance is depends upon R is equals to L by R is proportional to L by E. Resistance is directly proportional to length of the conductor and inversely proportional to area of cross section. R is a resistance. This is directly proportional to length of the conductor and inversely proportional to area of cross section. Now, if we put this proportionality symbol, R is equals to rho into L by E, where this rho is known as resistivity, or you can call it specific resistance, where this rho is resistivity. Resistance. Here, the SI unit of R is the unit of R usually is expressed in terms of volts, but the SI unit of resistance is kg meter square per second cube ampere square. Second cube ampere square. The SI unit of resistance is kg meter square, because how we are going to express R is equals to, look at this in this expression, R is equals to, can I write R resistance is equals to V by I. V by I. So it is expressed in terms of ohm. V is nothing but potential difference, that is work per unit charge. So in place of W, I can write work per unit charge, work per unit charge divided by I. I is its unit is ampere. Current, its unit is ampere. So work is nothing but force into displacement or force into distance. In case of work, force into displacement divided by charge. What is the unit of charge? Charge. Q is equals to I into T, ampere into second. So here charge, its unit is ampere into second, into 1 by ampere. F is equals to mA, force into acceleration. F is in place of F, I can write mass into acceleration. Distance, that is displacement, is L divided by A into A square, ampere square, and it is second. In place of mass, unit of mass is kg. Acceleration, meter per second square. Length, meter divided by ampere square. So therefore the unit is kg meter square second cube per second cube and per ampere square. The SI unit of resistance is kg meter square per second cube and ampere square. This is the SI unit is known. It is not necessary. Just you can note the SI unit of resistance. SI unit of resistance. Now this is about resistance. Resistance is the obstruction, or you can call opposition to the flow of current, and it is given by rho into L by A, where rho is resistivity, L is length of conductor, and area of cross section A. The next term is resistance, second term resistivity. This is the first one, resistance. The second term is resistivity. Rho. So this resistivity, if you rearrange this expression, what is the formula for resistivity? Resistivity is equal to R into A divided by L. R into A by L. This is the formula of resistivity. So how we are going to define? If we substitute A is equal to area of cross section is equal to 1 centimeter square and length is equal to 1 centimeter, in that case, if A is equal to 1, L is equal to 1, R is equal to 1. So how we are going to define? Resistivity is nothing but it is the resistance of a solution whose length is 1 centimeter and area of cross section is 1 centimeter square. The resistance offered by a cubic centimeter solution is known as resistivity, and it is also known as specific resistance. This we can call specific resistance. But we are going to use resistivity. It is APPA recommended that in place of specific resistance, we need to use resistivity. So therefore, we are using the term resistivity. It is nothing but specific resistance. Specific length is 1 centimeter and area of cross section is 1 centimeter square. So if these two are unit values, then R is equal to 2. That is the resistance of a solution whose length is 1 centimeter, area of cross section is 1 centimeter square, is known as resistivity. And what is the unit of resistivity? For R, the unit is ohm. R is expressed in terms of ohms. Area of cross section is centimeter square, length centimeter. So one terms get cancelled. Its unit, resistivity unit is expressed in ohms centimeter. In SI terms, I can write ohms meter. This is the smaller unit. R, I can write ohm meter. Ohm meter is expressed. Resistance, resistivity. The next term is conductance. Conductance is represented by CRG. In some of the books, they have used the term C to represent conductance or G. So here I am using the term G to represent conductance. So here conductance is defined as the inverse of resistance. That is the easy with which the current flowing through the conductance. Easy with which, because resistance is opposition. So conductance is easy with which the current flows through it. So it is the inverse of resistance. Inverse of resistance is known as conductance, and its unit is 1 by ohm per ohm per ohm. Pronounced as per ohm is the unit. Conductance, resistance, resistivity, conductance. Next is conductivity. Conductivity, we can call specific conductance. Conductivity represented by APPA. It's like small k, APPA. So it is the inverse of resistivity. Resistance, resistivity, conductance, conductivity. Resistivity, conductance is the inverse of resistance. Conductivity is the inverse of resistivity. Specific conductance, that means conducting power of the ions present in 1 cubic centimeter solution, that is whose length is 1 centimeter and area of cross section is 1 centimeter square. If both the terms are unit, then this conductivity is known as specific conductance. Conductance is known as specific conductance, which is also known as conductivity. So this conductivity is given by K is the inverse of resistivity 1 by 1. Let us substitute K is equals to conductivity kappa is equals to 1 by resistivity. So what is the formula of resistivity? RA by L. So 1 by RA divided by L. So this goes to the numerator. So 1 by R into L by L. So this 1 by R term can be written as 1 by R is nothing but conductance, and this L by A is taken as cell constant. It is represented by G star. Conductivity is equals to conductance into cell constant, where this G star is nothing but G star is the cell constant. Its unit is per centimeter or per meter. It is cell constant. It is cell constant. Conductance, conductivity, resistance, resistivity. So and again, it is the conductivity part. Is it clear? So first, resistance. Resistance is nothing but opposition to the flow of current. It is directly proportional to length and inversely proportional to area of cross section, where rho is proportionality constant known as resistivity. Resistance is expressed in terms of ohms. Its SI unit is kg meter square per second cube ampere square. Resistivity is nothing but it is a resistance of a solution whose length is 1 centimeter and area of cross section is 1 centimeter square, and it is expressed by RA by L. Its unit is 4 centimeter in smaller units. But in SI centimeter, it is expressed in terms of meter. So 4 meter is the unit. Conductance means the easy with which the flow of current takes place. Conductance is represented by G and is the inverse of resistance. Its unit is per ohm. Per ohm. Conductivity is nothing but conducting power of the solution whose length and cross sections are unit centimeters. So it is the inverse of resistivity, and I have given the formula. So its unit is conductance unit is per ohm. Per ohm, cell constant unit is per centimeter. So this per ohm is nothing but it is expressed as Siemens. Per ohm is nothing but Siemens. So I can write Siemens per centimeter. Siemens per centimeter is the unit of conductivity. Siemens per centimeter is the unit of conductivity. So two more terms are there: molar conductance and equivalent conductance, along with its relation. Molar conductivity, equivalent conductivity, its relations, and then variations, its measurements, all rest we discuss in the next class. Okay, thank you.